An important topic from Calculus 1 is finding the maximums and minimums of a function along an interval. The basic calculus process is to start with a function and visualize it with a plot. Here I have a function already defined, and I will now plot it. From the plot, I will be able to get an idea of where the max or min is, and then we can go ahead and find the more exact location that we will be looking for when we grade your assignment. I can see that there is a maximum around this location here, and I can change the domain of my plot to zoom in a bit more. Here I've changed the domain to go from x equals 0 to x equals 5. Now, from the plot, I can see pretty clearly that the max should be about the point 2, x equals 2, down to y equals negative 20. But I'm guessing these aren't the exact values. So how do we find those exact values? We know that at any local max or min, the derivative of the function is equal to 0. That's because the derivative is the value of the slope of the tangent line at any point on the curve. So around x equals 1, the tangent line has a positive slope. At about x equals 4, the tangent line, of course, has a negative slope. And now at this maximum in between, we know that the tangent line will have a horizontal slope of 0. So using FindRoot, we can set the derivative to be equal to 0 using the double equals notation, and solve for the input variable along with an initial guess to begin the FindRoot algorithms. From before, we could see from the plot that the max should be near x equals 2, so that was my initial guess here. This is how we input an initial guess for the input variable. From FindRoot's output, we get a value for the independent variable that satisfies our equality. Now we can check that the output we are getting makes sense with respect to the plot. Indeed, the answer of 2.17736 is quite close to our initial guess of x equals 2. I can also see that the 0.17736 is a little bit to the right of x equals 2, and that also matches up with what I'm seeing from the plot, that the maximum is right about here, and that if I trace it down, that would be just a little bit to the right of 2, and that's indeed what FindRoot is telling us. Finally, we want to know what the maximum y value is that corresponds to the x value we just found. I can plug the output from FindRoot back into my original function to get the y value. Here we can highlight the output, right-click, click copy, and paste that into the square brackets of my original function. If I evaluate our function at that location, I see that the max occurs at negative 19.382. Indeed, that is close to my initial guess that the y equals about negative 20. And I can see that the curve does rise a bit above negative 20. So I am sure that I'm getting the maximum here. Thus, I have found the maximum at x equals 2.17736 and y equals negative 19.382. As you can see, checking your answers with a plot is a great way to be sure that you are getting the answer you are looking for. As always, you can visit the Math Lab in Fisher 331 or contact us on Google Hangouts during open hours to get additional help.